Okay, so some of you know inheritance, I know. Lots of you don't. How many of you know inheritance? Lots of you, okay. And did you formally study it, or how many of you studied that formally in a course? A few. Yeah, people normally don't get a chance to reach inheritance in CS1 courses. And arrays they tend to. And arrays and strings are very similar, so if you've done strings, you basically know the concept of arrays. The arrays are more powerful, so more complicated. And I'm going to use an array-based example to illustrate inheritance. And in your coming assignment, you have to use arrays, so maybe it'll help you understand that assignment a little better also. Okay. And so some of you have used inheritance, and please don't go to sleep. You know, inheritance is very difficult to understand. You know, I still have trouble with it sometimes. So there's just a lot of we give you this powerful thing, and then you know, try to really understand how to use it and what exactly it means is sometimes hard. Okay, but let's go and see the word inheritance from outside computer science. So we see inheritance in ordinary English also, right? What other field of science uses inheritance? Biology. And do we use that in real life, in outside biology also? So we inherit persons' traits, okay? And so money after they die, right? Maybe their eyes and ears also, but that's less important maybe. Okay, so basically, you know, money after they die is a very, very good motivation for what we're going to do. I'm not saying that's a good thing to do, to look at. But what is it about? It's about getting something for free, right? Without doing any work. Okay? That's what we want to do in computer programming. We want to get some functionality without doing any work. Okay? And the precious thing in when we inherit money is, you know, property and money. And the precious thing in object-oriented programming that we want to inherit, that we don't want to do again and again, has to do with objects, has to do with classes. And what is the class consisting of, really? If I decompose a class, it consists of variables and methods. So I want to, and these are called members. So I want to inherit variables and methods from someone else. That's the whole goal. Okay? So you inherit ancestors' traits, benefactors' assets. Okay, we inherit members, which are methods and variables. Okay? Now, inheritance and is-a. We often use the word is-a in English, right? I am a professor, you are a student, I'm a man, you might be a woman. Can you see that relationship between inheritance and is-a? So think of biology, right? When in biology, we certain kind of, you know, mammals, a monkey inherits traits of mammals, right? And now a specific monkey is a monkey, and it's also, so there's related. It's also a mammal, okay? So human is a mammal, okay? Salmon is a fish, okay? And guess what? A Cartesian point is a point. Okay? And now with these interfaces, you get to understand the is-a relationship even in more depth. You'll see that inheritance interfaces, they're all part of this big family that has to do with is-a. Defining is-a relationships. Okay? And to motivate this, let me just take an example. Okay? And we'll do two examples, and we'll see that, you know, we could have used inheritance in these examples. And before we do the second example, let's just do the first example, and this has to do with arrays. And let's look at the problem, and let's go and see how we can do it. If I was to tell you just write a main method to do it, you know, you guys will do it in your sleep now, because you've done the first assignment and second assignment. But I want you now to go and do it properly. Okay? And where I don't give you the classes, and you say, why do I have a scanner bean? Oh yeah, now I understand why I had a scanner bean, you know. And so we're going to just go and say, okay, you figure out what the classes are. Okay? And I've always told you this is a very challenging problem. You can be as mature and intelligent as possible, and still I give you a new problem, and you really have to scratch your head. and then you won't get it right anyway. Okay, and then you say, let me redo it, and now I probably got it. I got it better at least. Okay, so this is again decomposing a program into objects is what really object-oriented programming is. Learning what are public variables, what are instance methods, what are instance variables, they're just uninteresting unless you know how to create objects. You might as well just do MATLAB programming or some other language programming if you're not going to really create objects. Okay? They talk to each other. So the problem is following. I have a console window, okay, and I enter strings. These strings happen to be names, but they could be anything. Okay? And after I enter a string, I'd ask the computer, hey, what strings have I entered so far? And it goes and pretties the thing, it puts a bunch of stars and says, James Dean, stars. Okay? And then you say, okay, let me enter some more things. What I entered is in green. In Eclipse, you know that. And I say, Joe Doe, Jane Smith. And I say, okay, now tell me what all I have printed. What all I have entered. And it goes and prints out James Dean, Joe Doe, Jane Smith. Okay? And at some point I get tired and I say, okay, I've tested you enough. And I go and type Q. And it quits. Okay? Again, this is much simpler than what you guys have done in your first and second assignments. Okay? You go and check user input. You go and check if the first character is P or Q. If it's P or Q, you do something special. If it's not P or Q, then it must be a string that the person has entered. And then you go and do something with it. Okay? And so before we figure out how to write it, and again, we'll assume all the constraints I've given you. Okay? You can't use any libraries that do some magic for you. You have to go and begin from scratch. Okay? And we know the things we have to use. So when I go and enter James Dean, what is the computer program going to do with that string? Store it. Good. It's got to put it in its memory. Okay? And store it now in a bean of some kind. A bean with first component, second component, third component, fourth component. How far should I go? Sorry? Okay, so I can always okay, so again, you guys are just so good at scanning. You're saying, I'll take that string and find the first name and last name. And yes, that's an excellent thing to do. And I'll find the middle name if it exists. I'm a very easy to please user. Whatever I typed in, just spit it back. Okay, you don't have to go in reverse Jodo to, Dojo or put Do, comma Joe. Okay, I'm happy. I mean, I've tested you enough. Okay, you've survived. You're still here. So I don't have to test you anymore. Okay, so I need to store it. And could the storage object be a bean? And if it's a bean, then I could have a first component, second component, third component, fourth component, and then I start getting tired. Okay, so I'd want to allow not an arbitrary number of, can I ever say an infinite number of components, just before I take that? Can I ever say you can have infinite number of strings printed? Sorry? Okay. But my computer has got finite memory. So ultimately, there's got to be a limit. So when I tell you guys an array has a limit and you say, why just 100? Ultimately, there's always a limit. Okay, the computer doesn't have an infinite amount of memory. So it's got to have a limit. But I still want there to be a limit. And I don't want to say first, second, third, fourth. So again, this is a very simple question for most of you. I should store it, rather than in a bean, in an array of some kind. That's why arrays were invented. Because you get tired, first, second, third, fourth, you just say, they are the same type. That's the key here. They're all of the same type. So I can just have an array. Okay? So I could write a main program with an array in it, and I could store it in the array. But I just have one class. Now we are putting on our 401 hat. We want as many classes as possible. So now we're putting up, we want to be class designers. So tell me some helper class I could create. I could create an interface, of course, and that's good. Before I create the class, I should create an interface. Absolutely. Good. I'm glad somebody is buying my interface religion. Okay, I really argue. Okay. I'd argue that this is from first principles. I can argue for it, so it's not religion. But, the fact is a lot of people don't do it. Okay. And after you see this, after you leave this class, you'll again see your other instructors using class names as types and saying, who was that crazy guy who told you to use interfaces? And then you'll have to make a judgment, who was crazy. Okay? So, so the interface, what would that interface be that we would want? So I want a helper class. I want some interface for it. I don't want the work to be all done in my main class. I have an array, and I'm going to have an array in my main program, and I'm going to have some other data structure also in the main program. Those of you who finished assignment number, whatever it is due for. What else am I going to have in that program to do the print? I'm going to have a variable that is the array. And do I have another variable also? When I do a print, a filled part, position number, right? Position, you can say, is the index you iterate over. When I do the print, I go from 0 till whatever I have filled. Whatever I have filled is smaller than my length. That is the whole point of having those two arrays in your assignment. In one array, you go and keep filling things. You keep a count of how many elements you have. And then you say, okay, I have 10 elements. I'm going to create an array of size 10 and fill it up completely. Okay? So I need an array. I have an array and I have a variable in my main program. So rather than going perhaps to the interface, could I imagine a class that combines that array variable and the array and the size field together into one class? And what would be the interface of that class that the main program could use now? What does the main program really need from that class? Yeah.
It needs to be able to send it a size of the array and so that the input of the array and get the array.
Okay, so let's just get it right. Send is sort of, so it has to go and somehow have a method that takes as parameter an integer.
An integer for the size of the array.
So I'm the main program. Okay, so you're saying size meaning the limit? Okay, so you go and say, okay, you start off the object and you say, this is your max size. Okay, that's good. I'm not going to be as good as you. I'm going to just say that's hardwired as a constant. Okay, so the max limit is going to be hardwired as a constant. Now, what else does the main program have to send this object?
Strings.
Every time you add a string, it has to send a string. So, that's what you're going to say? And what would you call the method that takes a string as an argument? What's a good name? Set string. But set string seems to mean that there's only one string. Add string. Or just add. Or add element. Java can never make up its mind, neither can I. Nobody, should it be add? Should it be add element? Java had a class called vector which said add element. Then they said, oh, we don't like vector. We'll create something else. We'll call it array list. And that has add. Okay, so these are all good names. So I need to go and send it a string. And do I need to get something from that array also? From that interface?
You have to get the value, the value that's in the array.
So I have to get not just a value, but? And how might I get the values? What kind of interface might I have? So, but I don't want the whole array. If I get the array, I get the array with this length field, and I don't know what part is filled, what is not filled. That's why. So instead of getting the whole array, I want what? Yeah, an iterator. So help us define what an iterator might. But remember, I might want. Yeah, you're getting a little too advanced for me here. Yeah.
Would you like how we like a get token?
So like a get. So rather than saying get token, I want to say get what? Element. And I want to specify the element by index. Okay, so we're going to be a little simpler than you. Okay? We're going to just say get, rather than saying get element, get first component, get second component, I'm just going to say get element, and I'm going to pass an argument that happens to be the index of the element. And then how do I know when to stop? So get element. No. So if I was to deal with null values, then yeah, I can probably get the whole array and see how many elements are null and not. But the whole point is that I want that to be abstracted away. Okay? So I go and say get element, and I want to say get element 0, get element 1 to get element.
While the index is less than the size of the array.
Size of the array or size of the filled part of the array?
That.
Size of the filled part of the array. And how do I know how many elements have been? I don't even know there's an array underneath, by the way. I'm just saying you're a magical object. You keep it in an array list, vector. I don't care. Give me the ith element and give me.
Index less than the number of things.
And so how do I know number of elements? And who's going to keep track of number of elements we've added? A counter in the array or the user of the array? Okay, so there's a main class, there's this new class we're defining. The main class is just going to say add, right? And then it's going to say print. We want the main class to do as little work as possible. Okay? So the main class is going to say add, then it says I want to print, it says add, get 0, get 1, and then it needs to know from the other class what?
So the other class has a variable that starts at 0 and increments 1 up each time. Each time you add another string.
Yeah, so the other class is keeping track of that, and my main class needs to know that number so that it knows how many times to say get. Right? The main class is the one printing. Okay? The other class is not printing. So the main class needs to say get 0, get 1, get 2, get, and then it needs from the other class a size method. The method just tells it how many elements have been filled. And if you think about arrays, that is what arrays give you. They give you length. And they say this is my length and you want now this length corresponds to something that what you filled. Okay? So we're not objects, and we're going to have an add element. I'm pushing elements in there. An element add, which takes as an argument an int value. I haven't mentioned this here. And a size thing that says how many elements have you filled. That count is being kept by this particular class. We know that. Okay? And it can just return that value as a public property. Okay? Because it is not doing the printing. The printing is being done by main. There are 10 zillions of ways of printing something. Why should this particular class commit itself to how it prints? Let the user of the class go and do the printing. So that means the user of the class must know how to get the 0th element, the first element, the second element, and it has to also know what the size is. Okay? And basically, I have derived for you the interface that array, list, and vector have in a very simple fashion. Okay? Some of the methods these two classes have. Okay? If I was to tell you, guys who've used array list, how to do this, you'd say, oh, I'm just going to use a dynamic array, which is what you'll call it. It's not quite a dynamic array. It's an object that has an array, perhaps an array inside it. It could be what's called a linked list also. It could be anything. But we are just going to have this particular interface. And we know what our class is going to be like. It's going to implement all of these methods. And it's going to have a size field, this counter that we're keeping track of. That keeps track of how many elements we've added. It's got a contents field, which is going to be our array. We know nothing else right now. We don't know about array lists and vectors. We haven't studied linked lists. So we're just going to keep an array. And it's got the max size constant, which is what I have. You could take this value as a constructor, a parameter, and create an array of that size. And internally, it's got a method called isFull, which says that, if I'm full and somebody goes and adds after that, I should do something, maybe throw an exception, maybe give an error message. So some function inside my class is going to check for that. Okay? So you see how I'm doing very hierarchical very top-down programming here. I started with the problem. I try to figure out that I'm going to have another class. What is that class going to have? These methods, and these are the variables. And I've done all this stuff before I start writing any code, and now I can show you the code. But any questions about this? Okay? And again, the fact that I have implements here means that there's probably more than one way to do this. And trust me, there are. There's so many ways to doing this particular thing. And Java has a lot of them. Okay? And I can show you the code now. The code follows. I say add element, string element. That's what I'm pushing in. That's what I'm sending. My size, which is an int. And my element at takes an index and returns a value. okay, which returns the value at that particular index. Okay, and you can call it get, you can call it many things. Okay, these are all valid names for it. Okay, and my implementation is again pretty simple. I have a string history, implement string history. I have exactly what I promised. I have a constant for max size. I create an array of that size, right? Exactly what you guys will be doing. I have this size variable, which is this counter you were talking about. It is initialized to 0. I have this size method. It's not a property. Okay, it's basically, you can think of all of the elements of this array that are filled as being the components, the logical components. Okay, and this is just telling you how many logical components there are. So it's not, I'm not calling it get size, I'm just calling it size because it's not really a property, and it's certainly not an editable property. You don't just set it directly. Okay? I say element at, which means contents index. Okay, that's all very simple. Is full, I've reached the end, so my size is equal to max size. And add element is saying if it's full, do something, Otherwise, I go and add the element at the current size field. So when I begin, the size is 0. So when I begin, I'm going to add to the 0th position. So this is the index of the next unfilled position. Okay? And then I'm going to say my next unfilled position is one more than what it used to be. Okay? You guys, you've done a lot of this by now. Okay? But this just shows you how we can write a modular program that involves arrays. Okay? Okay?
What is the syntax of your isFull method? Where it says return size equals max size?
Sorry, with my isFull method? Oh, so you guys, so firstly, I have this, the most precious resource for me when I teach programming is my slide size. Okay? So this is not very nicely formatted, and maybe it's confusing for that reason. You really should put you should put this in 3 different lines perhaps, but I was just trying to save on space. So I'm saying return. Okay, so what am I really saying here? So what if I was to really write down, if size equals max size, return true, else return false? Should the TAs, hit you on the knuckle and say, hey, bad programming? Or is that clearer to you?
This is clear.
This is, by the way, I see this a lot in CS1 and CS2. That is sort of what, when I explain this to you, that's how I explain it to you. And a lot of people think that way, but that's certainly less efficient. Okay? And you're just saying that, look, size is equal to max size is the assertion I make. If the assertion is true, I get true. If the assertion is false, I get false. Okay? Yeah, when I do CS1 again, I spend a lot of time on Boolean operations, but I kind of assume you guys did this. But you can say A less than B, return 5 less than 3. That's going to be true. False. Okay? And 3 less than 5 is going to be true. So we can do things like that. Okay? Other things? And here's my main program that uses the history. Okay? And maybe you won't like the way I wrote this while loop. So I say names is a string history. I don't give it any argument because it's just going to allocate. I don't remember how many we were allocating. Okay? And then I say, hey, I'm just going to go in a loop. So I say while true. Okay? And then I go and use my library. I don't want to go and instantiate a scanner and do next line. I just say console.next read line, and I gave you guys what console looks like. And by the way, console is a library in object editor. You can use it. And I say, look, I'm very defensive. If the person did not enter anything, I'm not going to just throw up my hands and say nothing. And just let an exception come. So I say, look, if it's greater than 0, that means the user did input something. They just didn't hit return. Okay, I go and check if it's Q. If the first character is a Q. Okay, so if you can type Q, you can say quit. You can say QQ, and it'll all quit. You just get out of the loop. Okay, so this is not an infinite loop. I'm going to break out. Okay, at some point you will say Q. Okay, and until you say, I'll keep going. And then I go and check the first character and see if it's a P, and you can say P, print, PPP, and it'll all be printing. Otherwise, add something. Yeah.
If you have multiple
Okay. So that's a good point. So I have a loop, within a loop, within a loop, within a loop, which is, the kind of things we do in computer science a lot. And if I put in the innermost loop a break, does it break out of the outermost loop or does it break out to the next parent loop? Next parent loop. Okay, so you need to put breaks all the way up. This gives you more flexibility. Otherwise, if you had it breaking out overall, then, you just wouldn't have the flexibility. Is it good to have more than one break? Okay, first tell me, is it bad style for me to say while true? It works for this? So you're saying it's not bad style because I'm breaking after all, right? But maybe when the guy goes, if somebody reading the program has to go and find what my break is to know how I exited. But if I did not put a while true here, and if I just put a condition here, I'll have to repeat some code, by the way. Okay, I'll have to do some checking before the loop, then I have to do checking inside the loop. So I'm just being more concise. Now, should I have more than one break? So if we can agree at least that one break is okay, then maybe two breaks is okay. If one break was bad, then two breaks are certainly bad. Okay? It depends on the reader. This is a judgment call. And there may be more than one condition, so why not have more than one break there? In fact, there will be often more than one condition. So if there's more than one condition, what can you do? You can put them all in one big and maybe that's going to be more confusing. So I'm not going to make a judgment call on this, and I'd love to know whether you've studied textbooks that say there's an opinion here. But I personally, having programmed, don't feel. In fact, I like programming this way. By default, I just say while true, and then I decide when I'm going to exit. Okay? But I know some instructors don't say that this is bad. And, whether somebody can understand you or not is somewhat subjective. Okay? Other things? Okay. And here's my print method. My print method is the one, that's the static method here. And the print method was the one that was called when the user entered P. Okay? And I go and print out these things. And by the way, you probably have never seen stuff like this. But before GUIs got invented and people wanted to do things pretty, that's what they did. They would go and put a lot of stars. And my stars are prettier than your stars. And that was sort of the prettiness measure. Sorry? And then it became GUIs with black and white, and now it's how dare you even make it black and white. So it's our standards are going up all the time, okay, in terms of beauty from the computer. Okay, so this is my attempt at being beautiful here, and we go and say for element, and this is where if you know iterators, you can do nicer loops than this, okay. But we'll see iterators later, and we'll not only just see iterators, we might see iterators later, but if we see iterators, we'll implement iterators also. Okay, so we'll really understand what they mean. But for now, we're just going to say, and this is a nice for loop. I don't have any funny condition for breaking out. I know exactly what the condition is, how many times I'm going to go through before I enter the loop. So I'm just going to put a for loop here. And I have this size method from my strings, which is my array list, which is my string history. And by the way, why do you think I call it a history? I didn't call it a string list. I call it a string history. My methods were size, add, and get, right? So why did I call it a string history? As the class name. I mean, yeah, but why history? Why the word history? Yeah. I am not rewriting history. Okay? I'm just being faithful. Whatever you put in, you can't take back. Okay? So I'm not calling it a list, because list could mean that's why array list is something you can delete elements from. I don't want to give the user something that allows them to even delete. So I was very careful and I called it a history. Again, that's what I'm doing. I'm adding, yeah.
For assignment, every time you put it, you can put the array should be race, and then for like an even array should be race.
If I'm going to use the array again and again, but here in this program, I create the array once, and whatever you input, I don't have any clear command that says clear the array. We've cleared the history, which I'm going to come to, by the way. I'm just saying you can only add. This is history. Okay? So I'm just using the size, and I'm printing out everything that's in the history. Okay? Questions? Okay, now we're going to get things that are going to be much more interesting. Okay? And I'm not calling it a history now. I'm calling it, if you know what databases are, this is anything but a database in terms of its implementation. But the principle is that you can now erase things also. Okay? So I enter the same thing. I enter 3 names, and I go in, and it takes that, and I go and say print, and it goes and prints all 3 values, just as we did in history. Then I can go and say, oh, you know what? I entered so many elements, I've forgotten what I entered, and I've scrolled back, and I don't want to go look back. So please tell me if Jodo is M will stand for? I love your creativity and imagination there. That's good. Excellent. But the program doesn't know really, right? The program could use some AI. Sorry? So is a member. Okay? So M is a member. So is a member or not? It says true. And is Jane Doe a member? Oh, that's why you said male and female. Okay, I get it. So there's no Jane Doe. I haven't entered Jane Doe. Okay? So it says false. And I said, okay, I don't like Jane Doe in the history. I shouldn't have really entered him without Jane Doe, so I go and delete him. Okay? And now I print, and I get James Dean and Jane Smith. And then I say, I really don't like anything I entered. So I go and say C for clear. Okay? And I print, and all I get is my beautiful stars. Nothing else. Okay? Now we know how to do our history. Okay? And how did we do our history? We first created the interface, then we created the class, and so now just tell me what should the history interface get replaced by? So I have this history interface. Now I want a string database interface. Is my string database going to have an add element?
Yep.
A size?
Yep.
And an element add. What else does it have? Delete element, which takes as an argument a string or an index. We don't know which way. We could go either way. Okay, and we ultimately need to figure out what the index is, and it takes another one. What else? Clear. Okay. Now here's the deal. When you want to find out what method should be in an object, you need some help from anybody you can get help from. Okay, and typically if you're really doing an interactive application, you have a user who goes and says, I want this to be in the user interface. I'm the designer, you implement. Okay, this is really what happens in industry. If you go to Microsoft, they have developers and they have program managers who are the UI designers. Okay, and so they'll come up with a UI, and you can use the UI as a hint as to what your method should be. And did we do that? We had a P command. We didn't quite make a print method there, but we went and had methods that allow us to do print, because print is something we were going to do. Okay, not the collection, something the collection would do. But we had member Jodo, so maybe we can have a method called member Jodo also. We have a delete Jodo, we can have a delete string method. Okay? And we have a clear command, we can have a clear method. Okay? So the commands in the user interface, they will take parameters of some kind. Those parameters will become perhaps your method parameters. And those command names will perhaps become your method names. That is a very good clue as to how to create the UI. In fact, Object Editor is based on this philosophy. It says, Object Editor says your object came first. So I will create a UI based on what methods you had. Okay? And now I'm saying if you have a UI, you create an object based on what UI you have. So there is a correlation between the UI and the object. Okay? So here's my string database, and let's see which way we went. We have all the things we had from history, and we have some additional methods. And indeed, remove element takes a string argument, member, string element, clear. That's my interface. So I've become a designer. Okay? And my string database implementation, I'm not going to give you the whole implementation because it's a little long. And, this kind of manipulation, arrays, etc., is something you really should have done in your previous class. And even if you haven't done it, your first 2 assignments, 3 assignments have given you enough practice with it. Okay? So, but we'll just go through it. I'm going to still have a max size field, the contents field. I'm going to keep track of the size. And I'll do exactly what I used to do. And my remove element is going to do some magic. Okay? Perhaps it's going to call a remove element index. Okay, so I'm going to first write a simple method that is remove element, which takes an index as an argument, and remove element will call maybe will call some other method that goes and figures out the index of an element. That's what internal method I've added. Okay, so I go and given a string, I go and add an index of. I find this index. Given an index, I can go and remove that element. You can imagine removing really an array. You can't remove elements, so you can really what I'm going to do is shift elements up and down. Okay. So I have a shift up method to do that. So this becomes a little long, but it's doable by you guys. Yeah.
This is the thing that I don't understand about interfaces.
This is a class, by the way, but go ahead.
But you're implementing the string database, right?
Yes. Which is an interface.
And the interface, that interface is extending the other interface.
Okay, you're getting ahead of me.
Oh, sorry.
This is what it should do. So this is my motivational problem.
Well, the question is, why do we have to repeat the code at the top if it's inheriting it from, or why does, unless we're going to change it?
Okay, so why am I going and repeating the code from the previous slide? Okay,
Yes.
because I don't know better.
Oh, no, not.
I don't know inheritance at this point. I want to motivate inheritance. I want you to ask me that question so that I can say, here's a tool from Java. And you say, aha, lights are supposed to go up in your head at that time. But you already know it, so you say, this is boring. Okay?
Oh, no, I didn't mean it.
No, I'm just kidding you. But that's the whole point of this example. The point is not arrays. The point is, I don't want to go and do this. Okay? And I'm glad you find this tedium here. I'm glad you're lazy, because laziness is what invents. Laziness is the mother of invention. The guy who created a remote control was not a very athletic person, who wanted to exercise, say, oh yeah, another trip to the TV. He wanted to have his popcorn and no, that's really, I'm not kidding you. Lazy people are the ones who invent. So, okay. So we love, we've just understood arrays and sizes, and we've done it once, and we're going to do it another time because we just love it, okay? Okay, but you get the point, what this is going to do? Okay, now there's going to be some magic. This is the part that is the tricky part. And I do have slides in my notes on how to do this exact example. These are my CS1 slides. You're welcome to go look at it. But, textbooks and those do an excellent job of doing array manipulation. And I just don't, and this is, again, previous classes tend to do it, so I won't repeat it. Okay? So now the question becomes, okay, I was very good. I put a comment here from history. And so this way I was programming well, okay? But you want to be even better and say, why did I have to go and repeat the code I had already? And what tool can I get from a language that allows me to avoid repeating this, okay? And how can I reuse? And you use the word extension because in your head there was an extension going on, okay? In your head we started with string history, okay? And we went and extended, and we extended that interface in your head. Java doesn't know about extensions right now. We didn't even tell Java. We put a little comment there which Java just ignores and says, that's for the human being. That's not for me. Okay? And you went and logically extended that and had 3 more methods in it. Okay? And then you created a string history, and then again you logically extended that, and you went and created a class that has all the methods in a string history plus more. All the variables in a string history plus more. Okay, in your head. But you never told Java about it. We don't even know how to tell Java about it. And because we didn't tell Java about it, we can't reuse the code from there. Okay? So this is like saying, okay, I want a house with an extension. Okay? And rather than taking the original blueprint and just adding an extension to it, I go and trace it all over again and then add my room to it. In my head I'm doing that. But I don't know how to, I don't have a photocopier, I don't have a linker. So I know, this is what I do. Okay? So these are logical extensions, these are logically in a head, but they're not physically extensions because in the computer, I have repeated the code. In the computer, I've typed the code again. In the computer, they are not physical extensions. They are just new pieces of code. And there is nothing that is linking this code to the other code. Okay? So what I want to do instead is do a physical and logical extension. And this is where I go and say, I've created a string history, and I want to create something that extends it. And I want Java to understand this little arrow that I've put, saying, I am whatever this person is, plus this. Okay? And that's what, and I meaning the interface. So this is now the height of laziness. In interface, you don't have to write much. But even in the interface, I'm going to go and say, please give me all the headers from this particular interface. Okay? And I'm going to do the same thing with the string history. I'm going to say a string database has everything that a string history had, plus more, and this is the more thing. And hey, computer, you better understand what I mean. Okay? And how you make, I've got 1 minute. And if I was to do all of this stuff, what might I call, let's just do this. We'll repeat this next time, and we'll just have one more point to make. I'll make it next time. Okay? So, you guys can go. Okay, let's start. Questions? Sorry? Should assignment 3 have been returned by now? TAs? Has anybody got the assignment 3 back? Okay, they should have been, but I guess they have not been. I thought I saw some comment about assignment 3 problems on Piazza. I assume they have been returned, but none of the TAs here? So what's happening? You're still grading? Okay. So I have a meeting every Tuesday afternoon, so I get to hear the status at that point. Okay. Other questions?
So, remembering we want to comment the same commenting, and as long as our code, we need everything in a comprehensible manner is fine. Your assignment instructions haven't had a requirement for comment blocks.
Yeah, comment blocks. So, that's something I need to talk to them today about. So I've always said, do not comment for the sake of commenting. Okay? And I want to myself interpret what that message was. Was it that every assignment should have at least one comment, which is what I think it was saying. Okay? Not the message was phrased as every piece of code should have a comment. And the piece of code was left a little ambiguous. And I'm not saying that every assignment statement and every method and every class should be commented, but where you need comments, you should have comments. And if you get points deducted for lack of comments, please go to them and say, which comment am I missing? What is it that is ambiguous? Okay? So go back and ask them that. And I have always emphasized that do not say don't do it for the sake of commenting, and I'll maintain that. Okay? I have never said that. Okay, I'm going to say only that every piece of code that is confusing, okay, should have a comment. Okay, in other words, if you've used some obscure name, if the meaning of the method cannot be indicated by its name, okay, you don't want to type a very long name like I do, okay, then you should comment it. Okay, and you should probably have some comment giving the overall structure, of how your system algorithm or how your assignment works, which is what they were meaning. So since they haven't given the grades back, you don't know what they're taking points out for. So why don't you wait for that? But I'm not going to say every piece of code should have a comment, because I don't know what a piece of code is. A piece of code could be an assignment statement also, and sometimes those things are pretty obvious. Okay, so if you choose names well. And in fact, the whole purpose here is to make sure through annotations, through pattern name, through all kinds of annotations and names and good structure, you reduce the need for comments. That's the whole goal of this class. Okay, that doesn't mean it becomes zero, but the idea is to make it as close to 0 as possible. Okay, and so that's my statement. So the word block comment is not mine, okay, and so I can't defend it. Okay, and I don't think they've said that either in their thing. They've just said every piece of code should have some comments, which is, yeah, that's somebody, that's all somebody saying somebody heard somebody say that. Okay, so I didn't hear it directly from the TAs. Okay. So, I couldn't quite hear what they were saying, but I think it'll come pretty quickly. 4, we allow submissions till about a week afterwards, right? So we really can't start grading till all of them are in. It's not fair because you get your grades back and the ones who haven't submitted get to know more than, the others perhaps. But they should have really got assignment 3 graded. And for whatever reason it hasn't been, so I'll figure that out. Okay, but again, remember, if you ever lose points twice for the same thing, go back to them and said, I've already lost points for this. I've already lost points for having a space, not allowing a space at the end of my line. So don't take the points off again in assignment 2, and they should give you back the points. Okay. So if it's ever their problem that they did that, and it's easy to make that kind of mistake, but it's your job to find the mistakes.
Is there anything you can do about that chirping noise?
I just got these filters. I didn't even hear it. Okay. So, at some point after class, I'll go and does it come? Is it every day?
Yes.
Sorry?
It's only been today. So, I guess.
Did it just go away?
Yes.
You should speak more often. Somebody hears you. Other questions? Okay, good. So, last time we introduced this problem to motivate inheritance, okay? And we took an array-based example, and the idea was that you have a collection, okay? So arrays are really used to create collections, and we are not using the array in its raw form. We are creating a type around this particular array, okay? And the type we created was a string history. Okay, it was a collection of histories, so a collection of strings, hence the word string. And this is not a history we were going to rewrite, as I said last time. So this was something we only added to. We never deleted any element from it. So it's a history. Okay, and it's the interface, pretty much said what this was. It was consistent with the naming. So you allow an add. You allow somebody who's using the history to figure out how many elements there are in the history. And you allow somebody to figure out what the element is at a particular position. Okay, so we don't have getters here for every property because there's, we don't know how many properties there will be. Array could be instantiated with different lengths. So we don't have a first element, second element, third element. We just say element number. Okay, so that was my history. And we had a problem that just needed a history. Then we went to another problem that required us to change the element. So we could figure out whether some element existed in the history or not, in the collection or not. We could remove and we could clear. Okay, so since this history is mutating, we call it a database, though it's nothing like a real database. Okay, it's got the elements of being able to write. Okay, and we similarly had an implementation of string history, which was a string history. And we had an implementation of string database, which was a string database. Okay, and I'm not giving you the implementation here. The implementation was not that important. So this is a nice thing about interfaces. I can understand things at a higher level of abstraction without looking at detailed code. Okay, and we saw the string database had all the methods of string history. So I say that in a comment here. Okay, and this comment is useful. And I say from history, I've got these 3 methods. And then I said these are my additional methods. So somebody understanding string database can know that, okay, I've already understood string history before, so all I have to really think about that's new is this particular part. Okay? And that was my motivation. As when I presented this, somebody said, why don't you use inheritance? Okay? And that was, so that question can be posed in a more formal way through this picture. So I had the string history, and I'm using pictures now. Forget about Java syntax. This concept is applicable to many, many languages, or all object-oriented languages. So I have got the string history with these 3 methods in it. And I have string database with some additional methods. And through this little box here, I'm telling you what methods are common. Okay? So we know that string database is like string history, except it has these 3 other methods. Okay? That's what I just told you. And similarly with implementation, the implementation was a little bit more messy. We had for each method header here an implementation, and we also had some. These are the public elements of that class. Okay, and we had some non-public elements too, and some of these elements were methods like isFull that was not exported out, and then we had a constant, and we had 2 variables. Okay, so we said a string database is like a string history. Okay, it's got all these things, plus it's got a few more things. Okay, so so logically in my head, when I say like something except it has these additional things, in my head, in the programmer's head, I'm logically extending that code. Okay, and I'm not physically extending it. And we saw last time that physical extension means what I just said. It's like that thing, except it has more things. We want to tell Java about that. Okay? If we tell Java about it, then we don't have to do as much work, because Java says, okay, if you're telling me this, you don't have to reproduce all the elements that were there in the first type. I know they exist, and so I'll just assume they do. Like I'll just incorporate them in your new type. Okay? And similarly with the class. Okay? So we saw logical versus physical when we said logical structure and physical structure. Okay, physical structure was the way Java compiler structured it. Okay, them variables. Logical structure was in our head. A tool could use that. So it could extract that logical structure if you named your methods properly. But that was through the public interface, and that was in the programmer's head, whereas physically it was represented in a certain way. Similarly now, like I said last time, that if you've got a house and you want to build an extension to it, you could go and trace back the original design and then add the new room to it. Or you could just go and say, okay, just link to the previous design and say, I've added this element to it. Okay? So that's what we're doing. We're not duplicating our blueprint. We're just linking from one blueprint to another and saying, this is the addition. Okay? And the nice thing is if the first one changes, we don't have to go and change back the second one. Okay? We just inherit essentially what we extended. Okay? So that's the basic idea of inheritance, that we are telling Java what is common between 2 classes when one class is basically adding to another class. Or one type is adding to another type. Okay? So interface is a type, and a class is a type, and I've extended both the interface and the class in this case. Okay? Questions so far? Yeah.
So you have to extend the class even though you extended an interface?
Okay, so this is getting complicated, isn't it? All these relationships. So I have this blue line and I have this red line. The blue line is saying a string history is implementing this. The implement line is a pain from what kind of work. It says you shall do this work. Okay? So it's increasing your pain. Okay? But there's a relationship. It says these 2 types are related in some way. It's an implementation of that type. Okay? And we'll see that these 2 lines are actually forming together an is-a line later. You know, they're both, it's natural to get confused because at some level they are similar. Okay? But for now, the blue lines are increasing our headaches. And the red lines are increasing or reducing our headaches? They're reducing your headaches. Why? Because it says, I don't want to duplicate what was there. Okay? So the red lines are between similar elements. The red lines are between interfaces and between classes. You can't have a class extend an interface. You can't have an interface extend a class because they're different kinds of things. Okay? So that's a relationship. So because these 3 headers existed in this interface, these 3 implementations must exist here. Because these three headers existed here, these three headers need not be reproduced here. Because these three implementations existed here, these three implementations need not exist. So this is why one is increasing, one is reducing. Okay, and this will all get clearer. Okay?
Two thoughts. So like with interfaces and implements, I've always seen that as like a binding document between interfaces and others. When you implement, you're saying, hey, you should have these plus this.
You should have these, and you may have additional things too. Okay, but yes, it's saying that you should have these, plus you may have more. But that's what you say in Java. But what do I tell you? If you have more, those should also go in some interface.
Right, exactly. And that's what I wanted to ask you. So just wanted to make sure that when you're making a type of an object, whatever, you always want to use an interface for that.
That's my rule, yes. Whenever you're creating a class, you should always create an interface that the class implements so that we can talk about the class in abstract terms, so that we can do substitutions, and you'll appreciate that more and more as you program, as you go further in your project. Okay, but that's the rule that I have. That's not a rule that Java has.
Right.
Okay, so that's why things get a little confusing. Okay, so those of you who've seen inheritance before, when a class inherits from another class, the inherited class is called what of the inheriting class? Superclass. And the inheriting class is called what? Subclass. Okay? So some new terminology. Extends, superclass, subclass. When string database is a what of the string history, the interface, a sub, people are quiet now. Sub interface, super interface, that would be terminology, but if you Google for that, I don't think you'll find that on the net. Okay? And both a class and an interface are examples of types, right? You can type a variable using either a class or an interface, and I always told you, do not type it using a class, always type it using an interface. Okay? And so we could call these as supertypes and subtypes, and those, if you Google, you will find those terms. And they're typically used for interfaces and not for classes, just because, like I said, you should be typing using interfaces rather than classes. Classes are what you instantiate, interfaces are what you use for typing. Yeah.
Okay, so like supertype and subtype. Supertype is just like typing which the subtype is inherited from.
Yes. Supertype are the types that subtypes inherit from. Okay, so this is just terminology. Okay, and you've heard a lot of new terminology in this class, and this is just adding to it. Okay, and we're going to keep going. We aren't quite done here. Huh? So, okay. Other questions? So, like I said, this is all pictorially. This applies to any language. And then it becomes a question of syntax. So, this is our original string history and string database where everything was reproduced. Now we have a much cleaner picture. And the keyword we use, we could have used anything. We could have said inherits from. We could have said subclass of. But Java chooses the word, and we could have had some symbol. Java just has the word extends. Yeah.
So following interface string database, after it's extending string history, it's doing the work in the bottom box and the work in the top box.
Yes, exactly. So this particular database, this thing, is doing work here, and it's not doing work in the top box. Originally, it was doing work in the bottom box and the top box, which is what you just said. But it's doing the work here, and it's inheriting the work here. That's the way to look at it. Okay, that's when you said last time, we're inheriting our asset. It does both functions without reproducing it. Imagine in a web page, you can link to my web page, or you can copy all the contents into your web page, right? And if my web page changes and I go and put a new OE all there, you're stuck with all the errors, right? So I'm changing it once in there, and you just have a link to me, and if whatever I change, you inherit. That's basically it. Yeah.
Does extend string database extend string history? Does string history have private methods for string database to be able to access?
Okay, so the question is, if string history, the interface, remember this is an interface, had private methods, would those be inherited? So firstly, an interface, can it have private methods? Okay. So that question about what happens to private elements is something we'll just defer a little bit and, okay? But that's a very good question. So this seems pretty simple, right? Inheritance. I mean, what's there? You just say extends. Okay, nothing could be simpler. And some of you are smiling. Nothing could be more difficult. You know? I mean, this is just opening a can of worms. And if we can just understand this at the end of the class, we are doing very well. We can understand it to a basic level. Okay, this seems like a powerful concept. We want to inherit. But the moment we go and say extends, all kinds of questions arise. And you just named one of those questions. Do I inherit private members? Okay, maybe, maybe not. Okay, so the question becomes, yeah, KJ?
I think private, I have to say protected for the messages available
Okay.
to be accessible by the extended class. My question is, if let's say my, I guess using silent tree as an example, like let's say token, tokenizer extends, I mean it's interface dot token, and I extend a tokenizer.
The class.
Extend the class implement that interface as well, or do I have to recall?
Okay. So your question is, when a class implements an interface and it inherits from another class, what happens to the interfaces? Okay, so just hang on a little bit. I'm going to, all these questions are going to be answered. But like, you're just proving my point. That you say the word extends and you say, I understand. And then you say, I don't understand this, and I don't understand this. And honestly, I don't understand everything personally. Okay, I think I do. But there's probably something new in there, that ramification. And it's not only how it works. The tougher question is how to use it. And that the whole community has not understood properly. Okay, so if you know, there's all these versions of Java, and they have basically there was Java 1.0 and then Java 1.1, and Java 1.0 had used inheritance too much, and 1.1 said, hey, let's back off. That was bad. Okay, and the community of computer science has gone this way. At one time there was something called goto in a programming language. You could go to a line. You guys have probably never heard of it, and some of you have. And that was considered the way to program. And then there was somebody who wrote a paper, said goto considered harmful. And people said, oh yeah, you're right. And then it became banned speaking language. That's why you guys probably have never heard of it. And inheritance is going that way to some degree. Okay, that people have overused it. And again, when to use it, when not to use it. I'll give you some examples. But there was another question? Okay. So we understand at least what this example is doing. We've got two interfaces. One interface extends the other interface. We don't have any class. Okay? And what are we extends, inherits from? And what are we really getting? We are getting the characteristics of our supertype. And what is in an interface? We have named constants. And we have, and in this example, we don't have a named constant, but we could have had one. And we have these method headers. And those we are just getting for free. Okay? So members, that's a term that some of you might have heard of, especially if you learned C++. A member is what? Christian? Okay, I thought you were. So we have methods, we have variables. Whatever is inheritable, but actually these two things. Variables and methods are called members. Okay, C++, the language, invented this idea. Okay, so here the members are all methods. Okay. Now let's go to a class. Okay. This is the class I already wrote, or ideally somebody else wrote. Okay. And I have now gone and extended this class. And I don't show you the whole code. With the classes, they're talking about real code. It's getting messy. It's getting long. So I'm just putting ellipses because that code doesn't matter. And I'm inheriting now all the methods along with the implementations. So this is nice. Okay, we can all go and copy an interface header easily. But implementation is a little bit more painful. Okay? So we inherit those. And what else are we inheriting from the superclass? we are inheriting all the variables also. Okay? So we're inheriting this constant, this variable, all of this we don't have here. Yeah.
We're also inheriting the string history.
That's a very good question. Okay, we are also inheriting, or very good statement, that we're also inheriting the interface. Okay, so, implement string history, I don't have to go and repeat here. Okay, I'm implicitly inheriting that interface also. Okay, so this is nice. This is now what I'm showing you that I no longer have comment. I had a comment from string history. That comment has gone away. And it's got replaced by what? My verbose header. Okay, so string database extends a string history, implements string database. Okay, my header is getting very, very long, okay, and verbose. But the good news is that now I don't have to put that comment that said I'm inheriting from that. That comment will be redundant now. Anybody who understands inheritance knows you get all the methods from there. So that's just a useless comment. And it's always nice, like I just said, to go and replace comments with something that the programming language understands. Okay, replace comments with annotations. Okay, something, and because then you can do some interesting things with those, with something the language understands, can interpret. Okay, and that's what we've done here. Okay, yeah.
Okay, so since a string history already implemented string history, when you say a string database extends a string history, it's implementing string database and string history, correct?
Yes. So when I say a string database extends the string history, it implements the interfaces I mentioned here, plus the interfaces that my class mentions. Okay, superclass mentions. But it so happens that string database is an extension of string history. Right? We just saw that. So even if that rule wasn't there, even if the rule of inherited interface was not there, I would be an equivalent class. But you are exactly right. It's implementing string database and string history, and basically these are sets. And when we combine the sets together, we get one big, we get all the methods that's implementing, and duplicates get removed.
And you needed to implement a string database because of the methods you have to in the string database file.
And I needed to go and implement string database because a string history has methods that are not in string history, the interface, and those methods have to go somewhere. And you know the COM 401 rule, that those public methods have to go in some interface. So I put that in string database. Okay? And I have the next 3 slides actually going to elaborate on your point. But that's, again, examples of questions that arise when you start saying extends.
I was just going to ask, so is the only point of having an interface extend another interface to avoid copy and pasting if it would get caught by this anyway? Because you inherit, when you extend a class, you inherit its interface.
Yes, when you extend the class, you inherit its interface. So why did I go and implement this string database interface? Why does a string database, or why does string database interface extend string history? Why did string database extend string history? Because I'm an ultimate lazy programmer. I don't want to go and even copy the method headers.
I just wanted to make sure.
Yeah, so I don't want to copy those method headers. And so I just go and say extends. And that's not the real answer. The real answer is that if somebody changes those headers later, I inherit them. That is the real answer. Okay? The first copy and paste is easy. We're all experts, at it. What is wrong about copy and paste is when the original thing changes. And then you have to worry about changing it at the other place. And the way human beings work, at least the way I work sometimes, is that you change it one place, you've done the complicated thing. Now changing it in other places is the boring thing. The boring things you tend to forget. So it often happens that you change it one place and you forget to change the other places. And it's really, really nice to have it all at one place. Okay? Other questions? Yeah.
So you said that string database of the interface implements the string history interface.
Okay, now let's get this right. I did not say string database implements the interface. I said what? Extends. And it gets confusing. Yes, it's natural, but I said extends.
Right, so does it have to extend that one in order for you to implement that database?
Okay, so the question is, can a string history implement an interface that is not an extension of the interface of its superclass. Is that your question? Could string database have been an interface that was my original string database, which was not extending string history? Right? My original string database, I copied the code. And yes, you can implement anything. Okay? It so happens here we've done it. I told you all kind of questions arise, and we'll be lucky to answer all those questions at the end of the class. I'll get to you, yeah.
So I just want to have a few traces. I'm looking at the bottom box, it's public class string database extends the string history. So I'm looking at the extend string history, and I move up towards the top box. So the top box where it says a string history implements string history. Does that mean the public class a string database is also implementing string history?
Yeah, so is the question that a string history, is it implementing string history, the interface implemented by the superclass? And yes, this particular interface is inherited. That's what we meant.
It's kind of like a chain.
Yeah, I just get it's a chain.
Yeah.
Okay? And I'm just saying, go there for the rest.
Does extending a class copy the code or only just use?
Sorry, is extending a class?
Does it only extend the headers or does it extend the code?
Okay, so does it only extend the headers or only the code? In the case of interfaces, there's no question. We only have headers. In the case of class, what would you like it to be? You want the code too, right? So that's it. If you really wanted to extend the headers, you would implement that interface. Okay, which is not really extending, we're implementing.
So this is the benefit of always using interfaces of type or objects that you only do when you're using classes to essentially as types or objects that you're implements. I don't know if I'm saying this correctly, but if I'm always using a class when I'm creating an object, when I'm using interfaces instead, then I need to make the methods.
So you're still not entirely convinced why interfaces exist, right? That's kind of where we're going to, and you're trying to find a good reason for it.
I'm not that I'm going against it. I'm trying to
get all the ramifications. Yeah. You'll understand these things a little better as we go along. But again, remember there are two things. One is where it increases your work. One is that reduces your work. Think of interfaces as an obligation. Okay? And think of inheritance as sort of, fulfilling the obligation through some existing code. Just let's think of it at that way. Okay? Okay, many of your questions are in the next few slides. So if I went and said, and a string database extends a string history, implements string history, okay? Rather than saying implements string database, I said string history, would Java complain? No, Java would not complain because Java says every method in string history is in your class. That's all I check for. And will the TAs complain?
Yes.
The TAs will complain because
There's public methods in string database.
there are public methods in string database that are not in any interface implemented by this class. Okay? And that is why we put string database there. Okay, did I see a hand up here? Okay, so you lose some points here. Okay, you say, fine, I've lost these points. Okay, but I'm going to be even perhaps worse. Okay, so our Java will not complain because every public method is not in an interface. Now I don't even bother. I say extends a string history. Okay? Will Java complain? You don't have an interface implement, and we know that Java doesn't complain about you not having an interface. Will the TAs take out more points now? No, because I already implement the interface in string history. Okay, so this is good. In fact, TA should give you an extra point there saying, yes, you were bad, but you weren't bad in a good way. Okay, you went and you didn't go and, put a redundant implements there. You know how inheritance works. And by not putting that, you're doing, what you're saying is equivalent to the previous slide. Okay? Questions?
So the structure of the interfaces does string history extend string database?
Does a string history extend a string database? Can you inherit from your parent? Can your parent inherit back from you?
No.
So we've got to choose. We can't have cycles in this graph.
So then are we never using string database interface in this?
So here, I cannot type a string database using the string database interface. That is why the TAs will complain. You can only type it using string history, or you can type it using the class. When I said a string database implements string database, the interface, I can type an instance of that class using the using its interfaces. And now string database is no longer its interface, even though we know that it implements those methods. We haven't told Java about it. Okay? More questions? Okay. So a class implements all the interfaces implemented by its superclass. Okay, I'm saying this we said a few times. Okay, so we started with all this physical inheritance in the real world. We went to computer inheritance. Let's go back to this inheritance. Let's do an analogy to understand things a little better. So we said, human inherits the features of a primate, mammal, animal, and what should I go above animal? Organism, vegetable and animal, and above that, just a physical object. Okay? You might. Okay, we use this car analogy. So, sorry, I'm giving you a boring car here. So the deluxe Accord would inherit from a regular Accord, right? It has all the features of regular Accord plus more, ideally. I don't know if it does or not, okay? But that's the whole idea. You're getting something more. And anything above that? Honda. I have only limited space here. And physical object. Okay, so what do all Hondas have? All Hondas have the intersection of all the cars that they make, not the union.
Okay.
So by definition, a Honda is maybe the empty set. It could be the empty set, but it is somehow classified as Honda. Okay? Yeah. It only sets it as a tag, perhaps. But perhaps there is some engineering. There's just some things that are common, and you trust the engine, to be made in a certain way. Okay? So when you buy a Honda motorcycle, you're also a vehicle, right? So we have this nice hierarchy here. We understand this in the real world. Sorry, I'm going to something boring now. It's a string database and inherits from string history. Can I go higher? Those of you who know inheritance in Java? Object. Okay? And string history is not the only subclass of object. We've seen many subclasses. In fact, the class we've seen a lot of. So by the way, how do we know it inherits from object? We never said public class a string history extends object. Okay? If we don't say extend something, we extend object. So this was an implicit extension. It didn't have to be explicitly stated. Okay? And something else that is a subclass of that, string. Okay, so we understand that there is some commonality here. And object is not just this little placeholder. It's not like Honda, which is just like a make. Object has got real methods that are worth inheriting. Okay? So it's not as if, and different programming languages have gone different ways in whether you're going to have a common uniting superclass or not. So the first object-based language was a language, anybody remember I mentioned this language? It was invented in very, very long time ago. Smalltalk, but before Smalltalk, somebody guessed that decade right. I think it was somewhere 50s, 60s. There was a language in the 60s I mentioned. Simula 67. Okay, it was invented at AT&T Bell Labs. They were doing simulations, and simulations are easily created as objects. Similar 67 did not have inheritance. Okay? So then came Smalltalk, it had inheritance, and it had the class object, okay, as a unifying class. Then came C++, it said, nah, we don't need object. Okay? Things become simpler that way. So there was no object. Java went back and created object. Okay? And like I said, object is something that's really useful because there are interesting methods in it. Okay? Okay. Now I have the interface hierarchy. So I have the class hierarchy, I have an interface hierarchy. And I have string database, the interface, which extends string history, the interface, which extends, we never wrote anything. Did Java go and make an implicit interface for class objects that string history extends? As it turns out, not. Okay? So class object does not implement an interface. So according to our rules, that's bad. Okay? And like I told you, James Gosling, the inventor, was not inventing it so that I could go and criticize it in class at some other future. He was just doing it for himself. Okay? So just because he didn't do everything in a pure way, there's no judgment on him. But if he really was thinking far and trying to create a pure language, he would have created an interface for it. And in fact, lots of issues arise because object does not implement an interface. A lot of conceptual issues arise, and I'll get to those issues a little later when we talk about type checking. Okay? Type checking becomes a mess because it becomes messy to explain just because we don't have an interface. Okay? But that's something you need to know just from point of view of using Java. And again, there are languages that are even more pure than Java. One of these languages is a language called Eiffel, which was invented before Java, and where indeed the class object had an interface. Okay. Okay. So just to make this point clearer, a string history, we said implements string history, the interface. We never said extends object. If we really like typing, we could have said this. Okay, they're equivalent. So if you don't say extends object, Java automatically puts that phrase in there. Okay? Okay, and like I said, class object does have interesting methods that are worth inheriting. And 3 of these methods are here. ToString, which gives you a string representation of the object. Equals, which tells you if whether object is equal to another object or not. Not equals, but whether the contents are the same. And getClass, okay, which tells you what the class of an object is. Okay, so there was a question on Piazza saying, how do I know the class of an object? Should I put a property that's getClass? Okay, and I said, yeah, if you want to, okay, because we hadn't gotten to getClass, but in fact, you can find the class of an object, and the class of an object is another object, okay, of type class. So it gets all very interesting. And by the way, ToString, is that a method you might have used already? Unknowingly, you might not have called ToString, but has ToString been called for you? How? So by the way, before I get to that, let me just give you some examples. So is a string history .toString valid? It's valid because string history inherits from, it's an object. A new string database .toString, valid. Loan is some class we don't know about, but we said new alone. That must mean it's a class. That must mean we have an object. A new loan, directly or indirectly, is a subclass of object. So that's legal. String .toString, legal. String is an object, I just told you. No? Why is it not legal? It's a character. A character, this is a primitive value, okay? And in Java, we have primitive value as an object, and primitive value .toString doesn't work. Yeah.
On the previous one, you said that string extends object.
Yes. Every class indirectly or directly extends object.
How does object define string
If string extends object, I like the way you think. So it seems that into object, the notion of string is built in. That is true. That is why it has a method called toString. But it could have called it toText. and it will be the same thing. So object doesn't know the notion of the class string, though it knows there is something called, that kind of thing. And then how does it refer to that type? Now that's a good question. That's an excellent question. And there is something hardwired there to make it do that. Okay? It just returns, because it does return an object of type string. So string to that extent is built in. And so that's not a very clean design. That's good. That's a very good question. I never thought of that, actually. When I ask these questions, I'm not just testing you. I'm trying to learn, honestly. Every class I learn some 2 or 3 things new. And this is something I never thought of. But clearly, it has to refer to that type string there, because toString returns a string and not an object. So there is some recursion there, which is handled in some messy way. Okay? So this is not valid, and 5.toString is not valid. Okay? Okay, now we go back to the question. Have you guys already used toString before? And Christian just said, yes, every time you do a print line, and you say print line, if you say print line 5, you print line 6.0, a special print line is called for ints, another print line is called for doubles and characters. For each primitive type, you have a separate print line. But for all objects, there's one print line that says object print object.toString. Whatever toString returns, I'll print that. Okay? Questions? Okay. Okay, we've seen one example of inheritance. Hopefully there's more examples. Okay, and it's got all these complicated implications, so hopefully we can use it a lot. So let's go and see it being used in another example. So what did we do? We created a history, and then from that we created a database. And this was a user interface I used to motivate the database, that you are allowed to enter a few strings, and after you entered them, it prints out everything that was in the database, and you can check if something is a member. It will return true. You can go and delete an element, and you can print it later, and it will delete that element. And for those of you, I didn't quite show you the implementation, but what if I had gone and said James Dean, Jodo, Jane Smith? So I had repeated each element twice, and I had said P. Do you guys remember what my code would have done? I didn't quite show you the code, but the way I described the code, what would it have printed out the duplicates? Yes, the semantics were whatever you put in, you get out. Okay? And let's start with the user interface. That doesn't do that. Okay, now we're trying to be smarter. So we have all the commands that we had in the previous user interface, except that a print command now is printing out only the unique elements in that collection. Okay, so the collection is now a set. And why am I calling it an ordered set? Am I sorting it? In what order am I printing these elements? In the order in which I first received them. Okay? So I did get rid of the duplicates, but I kept the non-duplicates in a particular order. Okay, that's just what I have here. Sets are not inherently ordered. Okay, I've got this funny thing which is an ordered set. Okay? Okay, so now we got to put our inheritance hats on again. Do I need a new interface? So, do I need to have any methods other than these? No. I told you that we can identify the operations from the user interface. And I just told you my user interface never changed. I do all the same operations. I enter, I do print, I do member, all of those things remain the same. Okay? So I don't need a new interface, which means I don't have to add new methods to my, to my class. I don't have to go and add new method headers. But clearly I do need a new implementation, right? Because this thing is behaving separately. So can we quickly, in our head, figure out the algorithm for doing the strings? Before that question? Okay. So how would this string set change now? If not member, we already have a member, very conveniently a member function. If not, so when our add element is called, and add element is defined not in string database, but in string history, I would go and say, and I would define a new add element, which will just check if it's a member or not, and if it's not a member, add it, otherwise just ignore it. So my string set, would be an extension of a string history or a string database. A string database. I want all of these things. But I want to go and change one of the methods I inherited, not from my immediate superclass, but my grand superclass. Okay, that's not a technical term. Okay, but my superclass is superclass. Okay, and so no new interface needed. And I would just go and create a string set where I don't create any new kind of method. I create another implementation of a method I already was implementing, my superclass was implementing. Okay? And this does something different, which we just saw what that did. So this is nice. I can be choosy about what I inherit. I don't have to get everything in my superclass. I can say, yeah, these things I like, these things I don't like. Whatever I don't like, I can re-implement myself. Okay, this is really, really nice. It also creates more confusion. Okay, but what we're doing is, it's not all or nothing. Either you get the whole superclass, or you go and repeat all the code. You can say, I get these things, and I change these things. Okay, and what would be the English word for changing something I have inherited? Override? Is that from your Java knowledge, or was that from English? From English? That's good. Computer scientists don't always do a good job of creating intuitive words. I'm glad that they did a good this. Okay? So this method, add element, got overridden, and this method overrode that. Okay? So we have superclass, supertype, subclass, subtype, and a subclass can override a method inherited from its immediate superclass or its superclass and so forth. Okay, from one of the things. Okay, that's the basic concept, that you can override. Okay, exactly how we do the overriding? Well, here is what this is the add element from string history, my grand superclass, and this is an add element from my own class. And I had the same signature, so we know that we are not. If I did not have the same signature, I would be overloading the method. Okay, I'll be creating a separate header, which is a different method. I have identical header. In fact, I can put a little annotation saying @override. And if I put a little annotation called @override, Java says, oh, okay, I'll look for another method signature of that kind from your superclass. And if it doesn't exist, it says, there's some confusion in your head. Okay, and so that's actually a good, I should have really put that annotation here. So I say if member element, return, don't do anything. I could have put a little error message, but you're allowed to add duplicates to a set. It's not erroneous. You just don't store them. Otherwise, I did exactly what my previous add element did. Okay? So I'm being pretty good. I am rewriting only add element. I'm not rewriting member. I'm not rewriting size. Okay? So I'm doing some work, but not doing all of the work. Anybody a little unhappy? Firstly, do you guys understand this? Okay, that you've overridden. Anybody a little unhappy with the way I've coded? Yes, I haven't done as much coding as I could have, but have I done more coding than I should have? So what's duplicated?
Everything but the first line that you added.
Everything but the first line in the new add element. Okay, so we guys want to be lazy to the extreme.
Yes.
And also, more important, if that add element changed somehow, I want to get the benefits of it. So, supposing I don't tell you anything new about Java. Okay, some of you who've seen inheritance know exactly the elegant solution to this. But I don't let you add to Java. How could you get rid of this problem? With no new constructs. Yeah. Okay, I could say super dot something, but I haven't told you guys what super dot something is. So you've just gone to, so that's a solution, that's a nicer solution. But I want a solution that doesn't involve super, yeah.
You simplify, you do the if, and if that happens, if it returns else, you just call add element again.
Okay, so I could just say that. If member element return, otherwise add element. And what do you guys will think will happen in that case?
It needs to call
So you'll get what? You'll get into how long a loop? Forever. So how'll that be manifested, by the way? What do you think will happen on the computer? You do it in Eclipse. Memory overflow. It'll say stack overflow. Okay, there's many portions of memory, and stack is where you sort of call methods. And the thing is that your computer will freeze, nothing will happen, and the computers are very fast. You have a lot of memory. So you say, how can I ever overflow the stack? But your computers are very fast also. So they can very quickly add up memory. So ultimately, your fast computer will fill up its large memory, and you'll get a stack overflow. Okay? So we don't want that solution. I'm not allowing you to use super. Any other thing you could have done using your existing concepts? Yeah.
Create a separate method in superclass, like say force add element, which always has an element. Then superclass add element would just call force add element, but in the subclass add element will cursive check and then force it.
Excellent. So what you do is that in string history, you put a method called force add element, which is always does it. And now your add element in string history will just simply call force add element. Okay? And this particular and that force add element is not something you're overriding. So that is still visible here. And your add element will go and say if member element return, otherwise force add element. Okay? That's probably a nicer name. And I've got a little more boring name. So in my history, I will say I'm a history. So history always force add elements. Forces the add element. So I'll have an add element history, which is my history's add element. And this need not be public. Okay, I made it public, but it need not be. And my add element in that particular history will call this add element history. Okay? And my add element in the subclass will call add element history, and this way I can reuse. Okay, so the problem is that something that was visible upstairs from the superclass, I made invisible by making the same signature. So what I will do is I will force the thing I want to reuse to be a different signature so that I can refer to it later, so that I don't hide it. Okay, and I really should have called this not public, but sometimes it's useful to even have this force add element around in case somebody needs it. And of course, according to our rules, if I'm going to have this public method, I should put that in the interface also. Yeah.
Why did we need the second method in the first class?
Why did I need the second method in the first class? So why didn't I just simply call this add element history and call this add element? Right? And why did I call this here? Yeah.
Because your main method, when it receives a string, it goes to add element history.
Yeah, the main method goes to add element, this one. You want it to go to. Basically, I want uniformity in naming. So I want people who understand collections to think of a collection in terms of add element and not be interested in these nuances of how it's implemented. But this is really an implementation detail. In fact, if we did not make this public, if we had made this non-public, then it would have not have been available to the main class. So I would have had to do this. Okay? So you really you should name methods same way. Okay? It should not be that in PowerPoint, when you print, it's called print PowerPoint. And in Word, when you print, it's called print Word. Okay? Yes, creativity is good. But sometimes, it gets in your way of understanding things. So the uniformity is also a good idea. And for somebody who's using these classes, they should just think of add element. And how we internally implement it, whether we go and redo the code or we, call super, is another issue. There's another question? Yeah.
I was going to say, yeah, if you change the name, then you have to redo your code. Other objects that we're using add element, you'd have to change that.
Yeah, if you change it, then it will change other places. And we couldn't have nicely inherited that interface either. Right? Which we wanted to inherit. So think of all of these things adding up, and that's essentially what you're saying. Okay? Other things? Okay, so this is what you could do, but I have to create add element and add element history, and all these questions arise. Why did I have to go and, have two methods? So we can do what was suggested earlier. I can just say if member element return, and in fact, when I create a new method with the same signature, I don't entirely hide the inherited methods. Okay, I can refer to the inherited methods by saying add element. What does super mean here? The add element in my superclass, or didn't my superclass is a string database. String database does not have the add element. The add element, as I said, was in my grand superclass. So the super is the add element I've inherited from my superclass chain. So you go up the superclass chain, and the first method, the most you come across, is the one you're referring to. Okay? So if a string database also had an add element, I'll be referring to the string database super class and method, and not string history.
But wouldn't add element technically be in the next superclass that's being extended? The parent superclass extends.
Okay, so how do you, the question is, it's technically in that superclass, but it's inherited from that in the superclass. Okay, so it's physically, if by technically you mean physically sitting in my string history. It's inherited by my string database, and then inherited by me. So I get everything that my superclass has. So in that sense, yes, it's in my superclass, but it's physically in my grand superclass.
That's more of an ideological.
Actually, your point of view, I would say, is more ideological. My viewpoint, yeah.
The question more about the ideas behind it than
Yeah. It's ideological, whereas mine is very, implementation oriented. Okay, other questions?
I just wanted to point out I wasn't too far off. I just was super.
Yes, you weren't too far off. It's amazing how much time you can spend debugging a program when you're not too far off from the solution. You all know that. I spend sometimes a whole day. Typically, when Object Editor has a bug, it takes me a lot of time. And I never requires, or I don't remember the last time I required more than one line of change. Okay? But figuring out what that line was, and in your case, it would just freeze and you'd know you're in trouble. In my case, it is, the string shape doesn't move or isn't displayed. I say, oh my God, in the previous version it did. Now what did I do wrong here? Okay, the window doesn't have parameters. It really, suddenly, my method window was not working, and I had no clue, and I'd done something like a year before that I'd done that. So, yes. Okay. Other questions? Okay, so this is the inherited add element, okay, which is the ideological thing, that this is what I've inherited from my superclass chain. And if we had done exactly what you had said, forgotten about this, we would have a recursive call leading to infinite recursion. Okay, so now we are armed with even more knowledge. We can override methods, okay? And we are saying, okay, I'm a string set. I don't want to be just boring and extend everything. I'm just going to override add element. And can you imagine some methods here being overridden that you would like to override? ToString. You guys don't like the way ToString prints things. I've seen on Piazza. It just prints garbage. Okay? It's not exactly garbage. Okay? But is it garbage? It's telling you something. Okay? It's telling you it's a string set. And there's just some unique identifier for that object. So you can tell whether two objects are the same or not by looking at this. Okay? Yeah. Yeah, it's not quite the address, but it's some unique identifier. Maybe it's the address, but I don't think it's the address. Okay, but it is some unique identifier. Okay, and what I might want to do is write my own ToString so that I get something like this. Okay, where I get all the elements in the set, and every element except the last element is followed by a colon. Okay, this is something that I might want to do, and it's not too hard to write this method. But let me just go through this method because it shows you perhaps something you haven't seen before, and we can argue about whether this is bad code or good code. Okay, so I just go through a loop, and I keep adding to my initial null string contents of I. Okay, that's how I get every element, and then I need to go and make sure that I get a colon only after all elements but the last element. So this particular code is doing that. And how many of you have seen this funny thing here? Question mark, colon. One person. Two people. You like it? How many of you can figure out what I'm doing here? Yeah.
Saying if I is size minus 1, then strings of there exists, otherwise it's
Okay. I'm saying that I'm doing some if-else, like you said. Okay? But if-else is a statement. I'm going to convert if-else into a expression. That means it yields a value. And the value is either something in the then part or something in the else part. Okay? So I'm saying the value of this particular expression is whatever follows the question mark, which is this, if this condition is true, otherwise it is this. So we have condition, Boolean expression, value 1 of some type, and which is the type here, and value 2 of the same type. Okay? And it's what you choose is one of these two values depending on the Boolean expression. Okay? I did it here because, I can write smaller piece of code, but yeah.
So, this, I'm not sure which item to start.
So this is the true value, this is the false value. The first one is the true value, the second one is the false value, and before that is the expression.
Okay, this is the third item.
That's the semicolon, right? The first item is the expression. That's a Boolean expression. Then we have the then part and the else part. And then the semicolon, right?
So the syntax is parenthesis question mark, then the true value, a semicolon, and false.
Okay, it's actually not parentheses. I put it in parentheses to make it readable. It's Boolean expression, colon, first value, second value. Now, we spent all this time explaining what this is. Now, you guys think it's a good coding, what I did? No? Too confusing? Too confusing because you don't have the vocabulary. When somebody uses a lot of vocabulary, and you could say, what kind of English do I speak? You can go through a computer program and they say, college level, master's level, third grade level. Okay? And what kind of English should you speak? It's always good to go for the lower if you can. Okay? Why did I do this? And there was a language. So there are these things there are programs that are called write-only programs. You can never understand what they do. Okay, you wrote it once, you can never understand later what you understood. Okay, and there was a language called APL, which none of you have heard of, which could do in one line of code, what others did in, did in many lines of code. And some of you may not know this, but the inventor of APL is somebody from our department. And do you guys know about any famous person from our department? Fred Brooks. And what's his claim to fame? IBM. IBM 360. There's lots of things. The Research Triangle Park is because of him. Okay? He forced IBM to start a research wing here, and he said, and he at that time was basically guessing that, around that IBM would other industries would follow. He did the IBM 360. He did the version of Bytes that you have heard of. And he invented APL. He was one of the inventors of APL. No? I thought he was. Okay. So I'm glad Henry is here. He's another famous person from our department. But so I never attributed it to him, and then I talked to him once, and I'm going to have to talk to him directly at one point. Okay, because he was very closely linked with it, if not in the design. Okay? And the first computer science department in this country was, anybody know? Purdue. And the second computer science department was this, and he founded that. And actually, I was first a faculty member at Purdue and at UNC, so you can see which way I've been going. I've been following the history. And so he's got many things. He's got the equivalent of a Nobel Prize in computer science. And anybody know what that prize is called? Turing Award. Yeah. Anyway, So APL was a language that was known for doing such brief things, and people changed their mind about, whether this should be, you should have this code or not. But I personally like this, okay? And I will not say that this is a bad idea or a good idea. If you don't feel comfortable with it, don't use it. But try to use it and see whether you like it, okay? Okay, other questions? Okay. So my toString method, I'm applying it to a string set, right? And I'm getting a nicely printed string set. So it certainly has to be implemented in string set. Could it be implemented in a string database or a string history also? Yes. Would it be useful to implement it there? Because you could also print string histories or string databases. Okay? So should be defined in a string history as it is then available to and overridable by all subclasses. Okay? So what I did was I overrode toString in a string history. Okay? And now it's inheritable by everybody else. Okay? Questions? Okay. Supposing I wasn't going to be good. Supposing I really did implement toString in a string set. Here's the issue. This method refers to size field and contents field, both of which are declared in a string history. So the question now becomes, which was posed in the beginning of the class, should my toString in a string set be able to refer to variables that are not public, that are declared in my superclass, grand superclass, or whatever? Okay, that becomes the question. So, should non-public identifiers, be they methods, be they variables, be accessible in subclasses? Okay. And what do you guys think happens in Java, and what do you think should happen? So first, let's answer the question, should they be allowed? They were not public. And when we first knew about public and non-public, I said, look, public members are accessible in all other classes. I said that. When it's non-public, I was I was giving you a very clear answer. Okay? And public members for sure are accessible in all the other classes. When something is non-public, I know for sure that they're not accessible in all classes. That is for sure. Otherwise, they'd be the same as public. But should they be visible in some of the classes and not others? And what should be those classes? So in particular, should these particular methods be accessible in a string set? What do you guys think? Yes. Because same parent, I should be able to override, I should be able to override that stuff. Inherit it. I can write my interesting methods that way, right? I can write interesting methods referring to those variables in my superclass. Otherwise, I can't go and write methods that refer to them that extend the functionality in interesting ways. Supposing my string set was going to print things in a different way. Okay? Then I couldn't do it. Okay? So that's the answer, should. Now, those of you who know Java, are they visible? No? Okay, so we get into real complicated rules now. Okay? Rules I don't entirely appreciate. Okay? I have a little trouble remembering. It's just because I've taught this class so many times that I know these rules. Okay? And I'm saying this because, when there are things you have to remember, then they don't necessarily follow logic. And we have about a minute left. So let me quickly go through this and I'll revisit it next time. We have public members. They are accessible in all classes. That we understand clearly. That rule I understand. That's a clean rule. And now we get into these funny words. Protected. As if non-public is not protected. So protected means, it's a basic idea. I was thinking of this analogy before this class today. Think of your Facebook profile. Okay? Some parts are visible to the whole world. That's, I think, your public profile. Some are accessible to your friends, right? And we have two kinds of friends here. We have our family, which is our subclasses. And what other kind of friends? So those are one set of classes. We have another set of classes that's also our friends, and they are not our family, but classes in the same package. They are work companions. Somehow these classes are together forming one package that does some job. Okay? So we are related in some ways to our subclasses, and in other ways to other classes in the same package. So based on whether the class is in the package or in a subclass, some things may be visible and others may not. Okay? And next time we'll go and exactly see the rules, but that's the basic point. Okay, questions? Okay, so last time we introduced inheritance. And inheritance is a big deal in programming languages. If you don't have inheritance and you have objects and classes, the language is called object-based. Okay? And if you add inheritance, the language becomes object-oriented. Okay? That's sort of one definition that was given in the late 80s, and that's pretty much the definition today. So the exact terms obviously are not important. The point is that it's a big jump. Okay? And the jump doesn't look that big. You know, it seems it's pretty straightforward. You take an interface, you extend it, and you end up inheriting all the members in the interface. Okay, in which case, and in the case of interface, that's the constants and the public headers. Okay? You take a class, you extend it, and again you inherit all the members, but the members are now not only the methods headers, but also the implementations, and that creates all kinds of interesting issues. They're not just the constants, but also the variables, the things that can change. Plus, you inherit the interfaces that were declared in your class. Okay, so if your superclass implemented some interface, you are also implementing implicitly that interface. Again, you know, the jump doesn't seem that big. Maybe just people took a while to figure that this is a nice and interesting concept. Okay. And I said that, look, I can explain inheritance to you, and but it'll also opens a whole can of worms, and it can make your head hurt. Okay, so today we're going to make our heads hurt. Okay, and we're going to try to understand the implications of inheritance and what it really means and how we can use it, and maybe today and some of next time. Okay, so one issue that comes up is visibility of non-public things. So right at the beginning, you know, we said public class and the constants were public, but the variables were not public. And lots of students said, okay, if they're not public, let's make them private. Okay, that is the antonym of public. And I said, nah, not private, just not public. Okay, and I can't tell you why private is different from not public. And now we get into these subtleties. Okay, because if I just had public and private variables, then public and private members, identifiers actually, even a class name can be public or not public, then I would have two worlds, myself, my class, all the methods in my class, and all the other classes in the world. Okay, and if they are public, every class can access them, and if they are private, only my class can access them. Okay, it's a very simple world, and that's what I would have. But now I've added inheritance, and my subclasses are maybe more special, are different from rest of the classes. And I took the Facebook analogy last time that maybe they are my friends. Okay, and we don't just have a public profile and a non-public profile. We have public profile, which is the rest of the world, and then there's various groups of friends. Okay, and so maybe, and I posed the question last time, and I said, you know, should these variables which are not public, be accessible in the subclass? And all of you said, yeah, you know, because we want to do interesting things with it, so we should have them accessible. And so that was the question. Should non-public members be visible in subtypes? And we said yes, and the answer is yes if you want them to be, and no if you don't want them to be. And it's up to you how you just make the decision. So in fact, the world of classes, okay, that our members can be exposed to. So if we are a class, either we are public or not public, and then our members are public or not public. Okay, so the question is, am I as a class or interface visible to others? Are my members visible? So if my name is public or if my members are public, then all classes can access them. Of course, I can access them, my methods can access them, but all classes can. And then we group, we form two friend groups, if you will. Okay, one is my subtypes. Okay, so this applies to also interfaces. So my subtypes, and then my co-packaged classes in my package. Okay, and they can have special rights. So you can say, okay, and it's not quite that you can choose independently each set. And some of you know the answer, and the answer is not something you can derive logically. So I'll just give it to you. So they basically decided to have a hierarchical access control system. This is access control, right? Who can access these objects? Private means only my class can access these members. It's not visible to anybody anywhere else. Okay, this is like so in Facebook you don't send it out to anybody. Okay. Default is if you don't say anything. If you don't say public, whatever access you have is the default access. Okay, so you don't want to type anything. Don't type public. Don't type protected. Don't type private. Then it becomes default. So default is the next level of access. Then it's protected, and public is the most access. Okay, and those of you who know and who've dealt with these keywords, default would mean, or you can just try to use your logic. So after private, what should be the next level of access? Either my subclasses should get it, or my co-packaged classes should get the access. Subclasses? That's what my logic would say. Okay, but anybody know what Java really does? It's the co-packaged. So the co-packaged classes are somehow, I've got this analogy later, that subtypes are like your family, and co-packaged are like your co-workers. Right? Because you put all these classes together in one package because they do some task. So that's like your co-workers, and we're essentially saying co-workers have more precedence than family. Okay? And this is the problem with hierarchical access control. You have to make a decision of this kind. So default means co-packaged. Protected would mean then subtypes and packaged, because hierarchical. Okay, if it was not hierarchical, I could have different kinds. And these words are no help. Protected is anything that's not public is protected, right? So these words are not giving you help, and just because I've taught this course enough times and I've had to use this, I know this. But this is not something I can derive from the words. Okay? But the point is that co-packaged and subtype classes have special rights, and the co-packaged classes have more rights than the subtypes, and whether you can argue for that or not. Public means everybody does. Okay, so like I said, co-package is like co-workers, or if you have a stereo system, it's like the amplifiers and speakers that go together in one package. Okay, so they have to work together, and the idea is that work requires closer collaboration. Okay, and subtype is like family, or you've gone from an amplifier to a deluxe amplifier, so maybe you don't really need to access all the aspects of the original one, or maybe you do. Okay. So that's just a rule. The point is that not all classes are equal. Some are more equal than others. Okay, and that's your subclasses and co-packaged classes. Okay, so the packages you put your classes in are important now. Okay, and if you move around classes between packages among different packages, your accesses may go away that used to exist. Okay, questions? Okay. So this is not too difficult, except that you have to remember this. And as far as I'm concerned, what I'm going to tell you is, please don't make variables public. That's all I'm going to tell you. You make your choice whether you want them to be protected or default or private. We're not going to have any rule that says one or the other, because it's very hard to make the decision. It's a very case-by-case kind of situation. Okay? Okay. And by the way, that is the encapsulation rule. It's not my encapsulation rule. That is the encapsulation. Okay, just to make sure that we understand this, we have string history and string database both in the same package. So in string history database, I can access size, okay, because they're in the same package, right? And now I have moved this to a different package, and because I have moved it to a different package, my size field is no longer accessible, okay? And if I really want it to be in another package, and I want the size field to be visible, I would protect it. Okay, so that's when I get that's a next level from public, and where I'm giving almost everybody access except I'm giving access to both my co-packaged classes and my subclasses.
Question.
Yeah.
What if you use super or sub or whatever in the
If I sub,
yeah,
so this is my subclass. String database is my subclass.
right.
It wants to access size. For whatever reason, I've put it into another package.
Right.
I want the size field to be accessed. So I make the size field protected so that subclasses can. I don't want to make it public. I can't make it default.
What kind of classes can't access protected variables?
What kind of class cannot access protected variables? Something that's not in your package and not a subclass. Right? So a BMI spreadsheet. Hopefully I won't put the BMI spreadsheet and my collection in the same package. And it's not inheriting, so it can't access protected.
So does the package, or when a variable is protected, can only other classes from that package, are they the ones that are allowed to use that protected variable?
The package classes can, plus subclasses. Okay? So these two guys are in different packages. But it's a subclass. Okay? If in this particular package I put a Cartesian point, okay, which does not extend a string history, then it can't access. And we don't want it to access, right? Because the most flexible access that does not break the encapsulation rule is to make it protected. That gives you the most flexibility, and yet you're not breaking the encapsulation rule. Okay. So what we did was in this slide deck, we introduced collections. Okay, the string history, string database. I'm going to define collections a little bit more in a more organized fashion a little later. But we saw these things that can grow rather than an array is also a list, but it can't grow once it's been created. We saw these classes that could grow, and that was something new we learned. Okay, and we also used these classes to explain inheritance. So we learned two different concepts, and from this point, I can go and talk more about collections or talk more about inheritance. And I'm going to talk more about inheritance. We'll talk more about collections later. Okay, but I just want to show you that we've learned these two concepts, and this concept of collections is also going to be an important concept for you. You're going to be using a lot of collections whenever, in your future assignments, whenever you program in Java. And because collections are so important, Java has come up with a much more elaborate system of collections, which we'll get into later. But I just want to show you, point out that these collections are more understandable given the examples we've seen in this slide deck. Okay, and so we'll understand this better. We'll have to learn something about abstract classes also to really understand this collection organization, and later. Okay.